getting ready to contract. And then contraction of the ventricle happens around here. Okay, so next we're going to talk about number 3 here. Okay, filtration and reabsorption. This is a calculation type problem. Okay, so first, let me just draw it out. Okay, guys. So, what is hydrostatic pressure? It's pressure from the fluid in the capillaries, right? Pushing out, right? So it's the water pushing out from the capillaries. Right? That's the movement. That's if the more water is inside the capillaries, the more it's going to want to go out, right? Out it leaves the capillaries. So that's a pushing pressure out. And then oncotic pressure is due to what?
Proteins.
Proteins, right? So proteins, wherever it's located, will want to draw water in, wherever it is. Right? So if it's oncotic pressure from the capillaries, it's due to protein in the blood vessels drawing water into the capillaries or into the blood, the vasculature. Oncotic pressure from the tissue is due to proteins in the tissue or interstitial space, wanting to pull water into the tissue, into interstitial space. So pulling water out of the capillaries into the tissue. Does that make sense? So, and then tissue pressure or interstitial pressure is kind of like hydrostatic pressure of the capillaries, but it's the equivalent in the tissue. Okay? So the pushing pressure from inside the tissue. Okay? So, so what you do in terms of calculating the net movement of water is basically you figure out which direction each pressure is pointing, and then add the magnitude of the pressures that are going in the same direction, and then subtract the difference of opposing arrows. Does that make sense? So let's do an example. Okay, so if I told you hydrostatic capillary pressure is 10, oncotic capillary pressure is 4, oncotic tissue pressure is 5, and then tissue pressure or interstitial pressure is 7. Which way is the net movement? Out of the capillary. And by how much?
4.
4, right? So 10 plus 5 is 15 out, and then 4 plus 7 is 11 in. So 15 minus 11 is 4 out. But you may not have a drawing, right? I might just say, hydrostatic pressure is this, oncotic capillary pressure is this, oncotic tissue pressure is this, interstitial pressure is this. So you'll have to draw it out yourself, figure out which direction the arrows are going, and then make sure you've got the arrows that are going in the same direction. You add them up to get the net flow in or out, and then you subtract the difference between the two opposing arrows and tell me which way is it going and by how much. Does that make sense? So when you hear capillary or plasma, it means the same thing. So oncotic plasma pressure is the same thing as oncotic capillary pressure, right? It all refers to vasculature, right? When you hear interstitial tissue, interstitial fluid, or tissue, that is the same thing. I'm talking about outside of the capillary, right? So if you're hearing tissue, it means outside the capillary. Interstitial, that's outside the capillary, okay? So let's try a different problem. Tell me what direction it's going in and what's the magnitude.
10. Going up.
I heard 10.
Yes.
Anyone else? I heard 20.
30 in.
30. So I heard 20, 30, and 10. Who says 10? Raise your hand. Who says 20? Raise your hand. So there's about 4 of each. 4 or 5 of each. Who says 30? Raise your hand. Raise your one. So between 10 and 20, which one is it? Okay, in what direction? Out or in? Out, right? So we all agree it's out. So here. Oncotic capillary, 15. Hydrostatic pressure is 25. Oncotic tissue is 20. Tissue pressure is 10. These two add up to 45 going out. These two add up to 25 going in.
No, it's 20.
So 45 out, 25 in, 20 out. How do you determine what? Okay, so 45 are going out. So your total is 45. So we have a net of 45 out. So these two, 20 and 25, add up to 45, and they're both going out. That's why you add similar arrows, right? So these two are both going out, and they add up to 45. So the net is 45 out. These two are going in, and they add up to 25. So we've got a total of 45
I thought hydrostatic could be used interchangeably for the pressure. Like, wouldn't you have to specify hydrostatic capillary versus hydrostatic tissue?
Yeah. So.
Because you just put hydrostatic pressure. So when
Yeah, I just shortened it. Up there, I wrote hydrostatic capillary.
okay.
Okay. So, you can say hydrostatic plasma.
Okay, so tissue will never be called hydrostatic. I thought hydrostatic referred to the water.
Yeah, hydrostatic refers to the water, right? But sometimes you can split, so what I was saying was tissue pressure or interstitial pressure is sort of like hydrostatic pressure of the capillaries, but in the tissue.
But it won't ever be called hydrostatic.
Some folks may call it hydrostatic.
Okay, that's just why I got confused, because you didn't put hydrostatic capillary, you just put hydrostatic pressure.
Over here?
Yeah, see how you put hydrostatic? I just want you to specify capillary or tissue, because my understanding is it can be used interchangeably.
Yeah, okay, I'll make sure. So in this case, I meant hydrostatic capillary pressure.
Okay, that's good.
Okay.
That's why I was like, what do you?
So if it's tissue, it will be tissue pressure and interstitial pressure. Yeah. So, unless it says hydrostatic pressure of the tissue. Normally it's, you would hear it as hydrostatic pressure, capillary pressure, or interstitial pressure would be in the tissue, the equivalent in the tissue, or tissue pressure, which is big, or interstitial pressure. Okay. You guys want to do another problem like that, or should we move on? One more. Also, if you see the T, it means tissue, but you might see it as IF, depending on the book that you read, which is interstitial, right, fluid.
Out.
I heard 14. Anyone else? Is it in or out?
Out.
Out. Yeah. 14 out. So 30 out, 16 in, so you end up with 14 out. Okay? Okay, so any more questions? Okay, we're going to move on. Okay, so next we're going to do lymphatic system.